Hello everyone and welcome back to this next lecture. So in the previous lecture we had fixed a couple of bugs in our code. The one was then with respect to an incompatible assignment where we had actually assigned an integer to a union, whereas instead we should have actually assigned the integer to a member of the union that is compatible with that integer value. And the other one was a silly mistake with respect to how the OR can be assigned back to the IER register, right? There should be no space between the operator and the equal to sign. So with this, I'm going to bring the microcontroller kit back. Now in this lecture, I'm using the TMDSDOCK microcontroller kit. In the next lecture, I will be using the Launch XL F28069 kit. So you might now see the microcontroller in the video. This is exactly the same state we left it in, where we were connected GPIO 12, 20 and 32 to LEDs, right? In this video, you will also see the oscilloscope that has been connected to the output pin GPIO 12. The reason is because CPU timer 0 has a time interval of just 0.01 seconds, which you will not be able to see by a flashing LED. It is too fast for the human eye to follow. So I'm going to click on the debug button to download the code onto the microcontroller. So the code has been downloaded and now I'm going to run it with this run button. And now as you can see, the LED is flashing. So the blue LED is flashing because it is flashing at a time interval of 1.5 seconds. The red LED seems to be off, but it's important to remember that timer 2, which is connected to red LED, has a time interval of 60 seconds. So which means it is going to stay off for 60 seconds and it will stay on for 60 seconds. Now, as you can see, there seems to be absolutely no blinking on the white LED. But that's merely because the human eye cannot follow the flashing of that frequency. But if you notice on the oscilloscope, you will see there is a rectangular waveform. So I'm going to zoom in a little into the oscilloscope and you can see, I'm not sure if it's clear enough, but I have set the time period to be 5 milliseconds. That is, each time division is 5 milliseconds. And as you can see, the rectangular waveform has a 2 division width, which means it is 10 milliseconds in width when it stays high and 10 milliseconds when it stays low. This is exactly as we configured. And if we go back, we'll see that the red LED has now turned on, because now it will remain on for 60 seconds and then it will turn off after that. So this is clear that I hope you are also able to get these results. And with this, I'm going to stop the video of the microcontroller and I will terminate the code. And let us try a few other alternatives just to see what happens and where the certain catch-all situations can occur. So as I get back into the code, I will make a couple of changes which I told you before were just house cleaning. For example, I said we were setting the flag bit here, that is a timer interrupt flag bit. Now, the documentation does not say that this is essential. So let us try to comment this code and see if it makes a difference. It will not make a difference, but let us verify this for ourselves. So we are merely removing the cleanup option, and what this means is that when the timer interrupt is issued, the flag is set. The flag will remain set and it will always be set. So the only problem is if we are trying to ever read the flag register to see if the timer has been issued, that will not be possible because we are never clearing the flag. So let us try to do a compile. And there are no errors, so we are good to go. And now I'm going to debug so that we go into the microcontroller. But before that, let me bring the microcontroller back into the video. So the microcontroller is in its old state where the old code is already working. So I'm going to go and click on the debug button. And the code has been successfully downloaded. So now let's run the code And as you can see, there is no difference, right? The blue LED is flashing, the white LED is flashing, but too fast, but we can see from the rectangular waveform on the oscilloscope that we are still getting the correct results. So therefore, as I said, that interrupt flag bit is merely a housekeeping action. I would still recommend that you do it, because when you issue an interrupt and when you have serviced the interrupt, it's a good idea that you clean up after yourselves and you just reset all the flags. This way, if you ever need to access that flag in a control code, the flag will show the correct state. So I'm going to end the microcontroller video and I will terminate the code. Now, there is one more thing which we should check out, and this is a serious error. So for example, if we do not acknowledge this PI control register, this is a serious error, because remember, the processor will not clear this register, this flag. This flag is set when the processor begins to process an interrupt from a group. But the processor will not clear it when it is done. You must clear it manually. So if I comment this code and I compile it, there will be no error. But once an interrupt is serviced, no further interrupts will be serviced. And therefore, you will see that the square waveform or rectangular waveform disappears. So I'm going to bring the microcontroller back into the video and let me click on the debug button. So the code has been downloaded and let me run the code. Now, it makes you feel like nothing has changed, but if you look at this waveform, you'll see that there is no rectangular waveform any further. The reason is only one interrupt has been generated. One interrupt has been generated, we have toggled the pin, but after that, because we did not acknowledge the group bit in the peripheral acknowledge register, because of that, no further interrupts will be generated from that group, and this implies any timer 0 interrupts which the timer produces will not go through to the processor. So the processor will not deal with any more interrupts from that group if you do not clear the acknowledge button. So I'm going to end the microcontroller video and I'm going to terminate the code. So this was a quick catch-all that was very essential. That is, number one, always make sure that you clean up after yourselves. And for that matter, I'm going to uncomment both these lines, because my opinion, even when you are about to finish an interrupt service routine, please do clean up after yourself, and if any interrupt flags have been set, reset those flags so that if at all you want to know the state of your timer, you will know it by reading these flags. Whereas if you don't clean it up, then in that case the flags mean nothing, because they are just stuck at the same old value. So I hope you got exactly the same results that I got. If you faced any other issues, or if you didn't see flashing LEDs, or you tried something else, you are very welcome to try something totally different and check out with me if that's the result that you wanted to get. If that is the case, as always, use the Q&A forum. Otherwise, I will end this lecture, and in the next lecture, I will use the Launch Excel F28069 kit. So if you don't have that kit, you can skip to the last conclusion lecture. Otherwise, you can stay on and you can just watch anyway. Thank you so much for listening, and goodbye for now.